Hey everybody. In class today we talked about intercepts and how to find intercepts without having to create a table and plot all these points and draw our lines, right? We noticed that for x-intercepts, which we have in green here, in number 1, our equation y equals 2x minus 6, our x-intercept was 3, 0, right? And in our second equation that we graphed, x plus 2y equals negative 4, our y-intercept is negative 4, 0, right? And for both of these intercepts, we see that y equals 0 because those points are always on the x-axis. Y equals 0 for those points. And for the y-intercepts, for our first equation, we have 0, negative 6. Our second equation, we have 0, negative 2. For both of those, we notice that the x-coordinate is 0. X equals 0 for the y-intercepts. So we can use that information, y equals 0 and x equals 0, for the x-intercept and the y-intercept respectively, to solve our equations for x and y and find the intercepts without having to graph them. Let's take a look at a couple examples. In our first example, A, we have y equals 3x plus 5. So let's start by finding the x-intercept. We'll abbreviate there. Now, we know at the x-intercept, we know that y equals 0, right? So I can plug 0 into y because I know my y value is going to be 0 at the x-intercept. We have 0 equals 3x plus 5. Now we can solve for x. We can subtract 5 on both sides. 0 minus 5 is negative 5 equals 3x. Now I can divide by 3, and I get x equals negative 5 over 3. That's a fraction. So our x-intercept, we have a point. We have negative 5 over 3. That's our x-coordinate. And our y-coordinate, we know, is going to be 0. For the y-intercept, we're going to do the same thing. The only difference is at the y-intercept, remember, x is always 0 because it's going to be somewhere on the y-axis. So we plug that in to our equation. Y equals 3 times 0 plus 5. 3 times 0 is 0. 0 plus 5 is 5. So that one's actually a little bit shorter. Y equals 5. So we have the coordinate of our y-intercept. X is 0 and y is 5. Now we can plot both of these points on our graph. Finding the y and x-intercept actually makes graphing really easy. I know my y-intercept is 0, 5, so that's going to go right here, 0, 5 on the coordinate plane on the y-axis. And my x-intercept is negative 5 over 3, 0. Now, it might help to think of that as a decimal. I know negative 5 divided by 3 is negative 1.6 repeating, comma 0. So if I plot negative 1.6 repeating, that is going to be past negative 1. It's going to be closer to negative 2, but not too close. And there's our x-intercept right there. And now that we have these 2 points, we can draw a straight line between them. Remember, we only need 2 points to make a line. We have our x-intercept and our y-intercept. Those are 2 points. So we connect those two, and then we draw our arrows continuing our graph in those 2 directions. Let's do the same thing for example B here. Let's find the x-intercept. We know that y equals 0 there all the time. So if we plug that in, we get 6x equals negative 12 plus 3 times 0. 3 times 0 is 0. So that leaves us with 6x equals negative 12. We divide by 6. X equals negative 2. So our coordinates are negative 2, 0 for our x-intercept. For the y-intercept, do the same way we did it before. We know x equals 0. So we have 6 times 0 equals negative 12 plus 3 y, ran out of room over there, 6 times 0 is 0, 0 equals negative 12 plus 3y, add 12. We have 12 equals 3y now, and then we divide by 3. And we get y equals 4, or coordinates 0, 4. That's our y-intercept. So if we graph these, 0, 4 on the y-axis, we got a nice integer here this time for our x-intercept. We'll put that on the x-axis, negative 2, 0, and we will draw a line. A straight line, or at least as straight as we can make it. All right, let's take a look at one more example before we go. You are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in two sizes. Small tables seat 4 people, and large tables seat 6 people. The situation can be modeled by the equation 4x plus 6y equals 180, where x is the number of small tables and y is the number of large tables. Find the intercepts and graph the equation. So we're going to do this problem just like we did the last couple. We can start with the x-intercept. Doesn't really matter what we start with, x or y. I just always like to go in alphabetical order. X-intercept, we know y equals 0. So we got 4x plus 6 times 0 equals 180. 6 times 0 is 0, so we got 4x equals 180. And we divide by 4. We get x equals 45. So our x-intercept, x equals 45, y equals 0. Let's do the same thing for y. We know x equals 0 at the y-intercept, so 4 times 0 plus 6y equals 180. 4 times 0 is 0. That leaves us with 6y equals 180. And we will divide by 6. Y equals 30. So our y-intercept is 0, 30. All right, now let's graph this. We can draw our y and x axes. Because I'm dealing with a positive x-intercept and a positive y-intercept, I'm going to just graph the first quadrant. Now, my x-intercept is at 45. I'm going to count by 5s here. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 45. Got to extend my x-axis a little bit. And counting up, we'll go by 5s as well. 5, 10, 15, 20, 25, 30. Now, let's label. We'll label 10, 20, 30, and 40, and we'll do the same thing going up. Okay. So now I can plot my x and y intercepts. I have 45, 0 as my x-intercept, and I have 0, 30 as my y-intercept. Now, when I draw my line here, I'm going to be very careful to just stay between these 2 points. Think about our domain and range here. Since we're talking about tables, right, we can't have negative small tables. X represents small tables. We can't have negative small tables. We also can't have negative large tables because y represents the large tables. So our x and y intercepts here actually tell us something about this problem. This point is 0, 30, right? Since x is small tables and y is large tables, this tells us that we have 0 small tables, 30 large tables at that point. Down here, we have 45 small tables and 0 large tables. So these are both combinations that we can have that fit this situation. If we have 30 large tables that seat 6 each, that's 180 people. If we have 45 small tables that fit 4 each, that's 180 people. And then there's other points on this graph. Every other point on this graph represents a combination of small and large tables that would fit this equation and fit this entire situation. All right, we'll take a look at these a little more in depth tomorrow. Go ahead and finish up your notes, submit through Canvas, and I will see you then. Have a good night.